Hello, in this lecture we will find out the length of line segment X using three different methods. In the drawing we have a right triangle, triangle ABC is a right triangle, angle ABC equals to 90 degrees, angle DAC, this angle is equal to 45 degrees, side AB of triangle ABC equals to 6 units, side AD is equal to X, and we want to find out the length of side AD that is equal to X. And we also know that side DC is equal to 10 units. Okay, so we'll start with the first method. In the first method, we'll do a construction we will extend segment line AD by a straight line. And from point C, we will draw perpendicular to the extended AD. So, this angle is equal to 90 degrees according to our construction. Those two angles are equal to 90 degrees. And we will define the touching point between the perpendicular from point C and the extended AD as point E. So we have here right triangle, triangle AED, and this right triangle, we know that the sum of the angles must be equal to 180 degrees. So which angles we have inside the right triangle, triangle AEC, this right angle. In triangle AEC, we have one angle that equals to 45 degrees. This angle equals to 90 degrees according to our construction. And we have also the missing angle, angle ACE. In total, the sum of those three angles must be equal to 180 degrees. Here we will subtract 135 degrees from this equation, and we will get that the missing angle, angle ACE, is equal to 180 degrees minus 135 degrees is 45 degrees. So this angle, angle ACE, equals to 45 degrees. We will define DE as Y. DE equals to Y according to our definition. DE equals to Y. And therefore AE will be equal to X plus Y. And we know that in front of equal angles in the triangle, there are equal sides. Those two angles, they are equal to each other, therefore in front of those two equal angles, there must be an equal sides. That is to say, AE must be equal to EC. AE must be equal to EC according to the rule that in front of equal sides, in front of equal angles in the triangle, there are equal sides. That is to say, AE equals to EC, but AE equals to X plus Y. So A equals to X plus Y, and from this equation X plus Y equals to AE equals to EC, we derive that EC is also equals to X plus Y. is equals to x plus y, so we can write here with is equals to x plus y. Here, those two angles are vertex angles, and we know that vertex angles are equal to each other. So we can write down that this angle that is actually angle BDA is equal to this angle that is angle EDC. I'll repeat again. Angle BDA equals to angle EDC according to the rule that vertex angles are equal to each other. Vertex angles are equal to each other. So if we define angle ABD as alpha, we can write down that angle BDA equals to alpha. Then from this equation, alpha equals to angle BDA equals to angle EDC. We will derive that angle EDC is also equals to alpha. Okay? Angle EDC is also equals to alpha. So in the right triangle, triangle ABD, we have one angle that is equal to 90 degrees. This angle equals to alpha. So this angle BAD must be equal to 90 degrees minus alpha in order to complete the sum of the angles inside triangle ABD to 180 degrees. Here you can see that 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Likewise, in this triangle, the right triangle, triangle EDC, here angle ECD must be also equal to 90 degrees minus alpha in order to complete the sum of the angles inside triangle EDC to 180 degrees. 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. So here we actually proved that those two right triangles, the green right triangle, triangle ABD, is similar to the green right triangle, triangle DEC. Why those two right green triangles are similar to each other? Because they have all angles of triangle ABD can point to all the angles of triangle EDC. Those two angles are both equal to alpha. Those two angles, they are both equal to 90 degrees minus alpha, and those both angles, they are equal to 90 degrees. So I write it down. In the right triangle, triangle ABD, in the right green triangle, triangle EDC, we have those two angles, they are equal to each other, they are both equal to alpha. So angle BDA is equal to angle EDC, and both angles are equal to alpha. likewise, here, those two angles are also equal to each other. They are both equal to 90 degrees minus alpha. So angle BAD is equal to this angle that is actually angle ECD. And both angles are equal to 90 degrees minus alpha. I'll repeat again. Angle BDA is equal to angle ECD, and they are both equal to alpha. Angle BAD equals to angle ECD, and both angles they are equal to 90 degrees minus alpha. And those two angles they are also equal to each other. Each of them are right angle. So can write down that angle ABD, this angle is equal to this angle that is actually angle DEC, and they are both equal to 90 degrees. I'll repeat again. Angle ABD is equal to angle DEC, and they are both equal to 90 degrees. So we actually proved that all the angles of triangle ABD congruent to all the angles of triangle DEC, this triangle. Therefore, we actually proved that the right green triangle, triangle ABD, is similar. This is the sign of similar to the right triangle, triangle EDC. According to angle similarity rule. Okay? And so those two right green triangles are similar to each other. And from the fact that those two right green triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that AB over EC, AB over EC, is equal to BD over DE. And it is also equal to AD over DC. I'll repeat again, from the fact that the two green triangles are similar to each other, we will conclude that AB over EC equals to BD over DE, and it is equal to AD over DC. Okay? So here, AB equals to 6 units, so we will substitute AB by 6. EC equals to x plus y, we will substitute EC in equation number 1 by x plus y. And it is equal to BD over DE. DE equals to y, so we'll substitute DE by y. And it is equal to AD. AD is x, according to what is given as the question, over DC. DC is equal to 10 units. So, in conclusion, we found out that according to equation number 1, 6 over x plus y is equal to BD over y, and it is equal to x over 10. We'll find out the value of side BD in triangle ABD by implementing the Pythagoras theorem on the green eye triangle, triangle ABD. In the green eye triangle, triangle ABD, according to the Pythagoras theorem, here PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AD, so the square of the hypotenuse is AD squared. And it is equal to the sum of the squares of the perpendiculars. That is to say, it equals to AB squared plus BD squared. So here AD equals to x, so AD squared is x squared. AB equals to 6, and AB squared is 6 squared. 6 squared is 36 plus BD squared. So we got here that x squared equals to 36 plus BD squared. Here we'll subtract 36 from this equation, and we'll get that BD squared is equals to x squared minus 36. We'll take a root out of this equation, and we'll get that the value of BD is equal to the square root of x squared minus 36. Okay, we found out the value of BD. It is equal to the square root of x squared minus 36. Now we can substitute BD in equation number 1 here by square root of x squared minus 36. So we'll do it now, and we'll get that according to equation number 1, six over x plus y is equal to BD. BD is equal to square root of x squared minus 36 over y, and it is equal to x over 10. I'll repeat again. According to equation number 1, we found out that 6 over x plus y equals to square root of x squared minus 36 over y, and it is equal to x over 10. So here we will create two equations from this long equation, equation number 1. The first equation will be 6 over x plus y is equal to x over 10 here we will cross multiply this equation, equation number 1, and we get that according to equation number 1, 6 times 10 is 60, and 60 equals to x times x plus y. We'll open the brackets on this side of equation number 1, and we'll get that according to equation number 1, 60 equals to x times x is x squared plus xy. We'll subtract x squared from this equation, equation number 1, and we'll get that according to equation number 1, we found out that xy is equal to 60 minus x squared. Okay, x squared equals to 60 minus x squared according to equation number 1. In the next step we create second equation from this long equation. Actually, those two expressions, they are equal to each other, so we can write down this will be equation number 2, that square root of x squared minus 36 over y is equals to x over 10. We will cross multiply this equation number 2, and we get that according to equation number 2, 10 times square root of x squared minus 36 is equals to x times y. So we have second expression for the value of xy. In the next step we create equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. Okay, so according to equation number 3, we get that xy according to equation number 1, that is actually equals to 60 minus x squared. It must be equal to xy according to equation number 2, that is actually equals to 10 times square root of x squared minus 36. Here we will square this equation number 3, or we will square both sides of equation number 3, and we get that 60 minus x squared is equal to 10 squared is 100, and the square and the root will cancel each other, and we left only with x squared minus 36. Here we will open the brackets on both sides of equation number 3, and we will get it according to equation number 3. 60 minus x squared is equal to 60 squared, that is 3600, plus x squared that is x to the power of 4 minus 2 times 60 times x squared, and it is equal to 100 times x squared minus 100 times 36 is 3600. So here we will add 3600 to this equation, equation number 3, and we will get that according to equation number 3, $3,600 plus 3,600 is 7,200 plus x to the power of 4 minus 2 times 60 is minus 120 times x squared, and it is equal to 100 x squared. So here we'll subtract 100 x squared from this equation, equation number 3, and we'll get that according to equation number 3, x to the power of 4, and here we have minus 120 minus 100 is minus 220 x squared plus 7,200 equals to 0. Here we substitute minus 220x squared by minus 180x squared minus 40x squared. And we get that according to equation number 3, x to the power of 4 minus 180x squared minus 40x squared plus 7,200 equals to 0. If we will take x squared out of these two expressions as a common factor, and we get that according to equation number 3, here x squared is a common factor, so what is left from x to the power of 4 after we took from it x squared as a common factor, what is left is actually x squared. And what is left from minus 180 x squared after we took x squared as a common factor, what is left, it is actually minus 180. And from those two expressions, we take minus 40 as a common factor. What is left from minus 40x squared after we took minus 40 as a common factor? What is left is actually x squared. And what is left from 7,200 after we took minus 40 is a common factor, what is left, it is actually minus 180 because of the fact that minus 180 times minus 140, minus 180 times minus 40 equals to 7,200. So it is equal to 0. Here we take x squared minus 180 as a common factor out of those two expressions, and we will get that according to equation number 3, so x squared minus 180 is taken as a common factor, so what is left from this expression after we took from it x squared minus 180 as a common factor, what is left, it is actually x squared. And what is left from this expression after we took from it x squared minus 180 as a common factor, what is left is actually minus 40, and it equals to 0. So here we will have two solutions that are possible for x. The first solution for x is that x squared minus 180 equals to 0. And the second solution for x is x squared minus 40 equals to 0. So according to the first solution, we get that x squared is equal to 180. 180 is 36 times 5. We take out of this equation and we get that, according to equation number 1, x equals to the square root of 36 times 5. The square root of 36 is 6. 36 times square root of 5. That is actually equals to 13.41, that is greater than 10 units. I write it here. That according to the first solution, we found out that x equals to 6 times square root of 5. That is actually 13.41, that is greater than 10. This is the first solution for x. And we have also second solution for x. According to the second solution, x squared minus 40 equals to 0. That is to say, x squared equals to 40. We take a root out of this equation and we will get that x, according to equation number 2, x equals to the square root of 40. And 40 is 10 times 4, or 4 times 10. So we found out that according to the second solution, x equals to square root of 4 is 2 times square root of 10. That is to say, it is equals to 6.32 units. This is the second solution, that is less than 10 units. This is the second solution for x. In the next step, I will draw the right triangle ABD and this triangle ADC in this new page, and we will analyze the triangles in order to find out which solution is correct out of those two solutions. Which one is the correct one? So we have first of all the right triangle ABD. we define this angle as theta. This angle equals to alpha. And we also have triangle ADC. Actually, here the right triangle ABD, the green right triangle, has three interior angles, theta, 90 degrees, and alpha. And then it is also one external angle, angle ADC. This angle is external angle of the right triangle, triangle ABD. I will write it down. Angle ADC is an external angle of the right green triangle, triangle ABD. Okay? This angle ADC is an external angle of the right triangle, triangle ABD. And we have rule that is related to the size of any external angle of a triangle. According to rule number 1, external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. I'll read rule number 1 again. According to rule number 1, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So here we have the exterior angle, this angle is the exterior angle ADC, and according to rule number here, this is the exterior angle ADC, and according to rule number 1, the size of this exterior angle is equal to the sum of the two interior angles of triangle ABD that are not adjacent to it. Angle alpha is adjacent to angle ADC, and the two other interior angles that are not adjacent to angle ADC are theta and 90 degrees, and the sum of those two interior angles equals to 90 degrees plus theta. Okay? And we also know that the sum of the angles in any triangle is equal to 180 degrees. It is given us in the question that angle DAC equals to 45 degrees. And we also know that side DC equals to 10 units, according to what is given us in the question. So if we focus on triangle ADC, we know that the sum of the angles in triangle ADC must be equal to 180 degrees. So which angles we have in triangle ADC? We have this angle that is equal to 45 degrees, and we have this angle that is equal to 90 degrees plus theta, and we have the third angle that is the missing angle, angle ACD. Angle ACD. In total, the sum of those two angles must be equal to 180 degrees. Here we will subtract 145 degrees from this equation, and we get that theta plus the missing angle, angle ACD, is equal to 180 degrees minus 135 degrees is 45 degrees. Here we'll subtract theta from this equation, and we'll get that the missing angle, angle ACD, is equal to 45 degrees minus theta. Okay? This angle ACD equals to 45 degrees minus theta. This angle equals to 45 degrees minus theta. And from the drawing, it is very easy to see that this angle, angle ACD, is the smallest angle in triangle ADC. Okay, you can write down that angle ACD that is equal to 45 degrees minus theta is the smallest angle in triangle ACD. Okay? And we have rule that is related to the smallest angle of a triangle. According to rule number 2, the smallest angle in a triangle is always opposite the shortest sides. I'll read rule number 2 again. According to rule number 2, the smallest angle in a triangle is always opposite the shortest side. And therefore, according to rule number 2, angle ACD that is equal to 45 degrees minus theta is opposite side AD that is equal to x according to what is given us in the question. And because of the fact that the smallest angle is angle ADC, it is in front of the shortest sides. That is to say, AD that is equal to x is the shortest side in triangle ADC. According to rule number 2, AD that is equal to x is the shortest side in triangle ADC. Why? Because it is located in front the smallest angle, that is ADC, that is equal to 45 degrees minus theta. So if AD is the shortest angle, then it must be less than 10 units. Because this equals to 10 units, therefore AD that is equal to x must be less than side DC. So AD that is equal to x must be less than DC that is equal to 10 units. That is to say, we found out that x is less than 10 units. X must be less than 10 units. We found out, in conclusion, that x must be less than 10 units. And we add two solutions for x. The first solution for x is that x equals to 6.45 units. That is actually 13.41 units. It is greater than 10. And because of the fact that in the first solution x is greater than 10 units, this solution is incorrect solution because x must be less than 10 units. So this solution is incorrect solution. We cancel this solution and we will be left only with the second solution, that x equals to 2 times square root of 10, that is actually equals to 6.32 units, that is less than 10 units. In conclusion, we found out that the solution to the problem is that x equals to either 2 times square root of 2 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. In the next step, I will present to you how to find out the value of the length of line segment x using the first method, according to the second method. Okay? In the second solution, we'll do another construction. From point D, we'll draw a straight line to AC in such a way that the angle that will be created by the straight line and AC will be equal to 45 degrees. Okay, so here we'll draw a straight line on AC in such a way that this angle will be equal to 45 degrees. Okay, so if this point is E, then angle AED is equal to 45 degrees according to our construction. Okay? And here the sum of the angles in triangle ADE must be equal to 180 degrees. So which angles we have in triangle ADE? We have one angle that is equal to 45 degrees. The second angle is also equal to 45 degrees. And the missing angle is angle ADE. Actually, the sum of those three angles must be equal to 180 degrees. According to the rule, the sum of the angles in any triangle is equal to 180 degrees. 45 degrees plus 45 degrees is 90 degrees. So we subtract 90 degrees from this equation and we get that the missing angle, angle ADE, is equal to 180 degrees minus 90 degrees, it is 90 degrees. Okay, so this angle equals to 90 degrees. This is the right angle. In triangle, the right triangle, triangle ADE, we have two equal angles. And we have the rule that in front of equal angles in the triangle, there are equal sides. That is to say, AD must be equal to DE. AD must be equal to DE. But AD equals to X according to what is given as the question. So from this equation, X equals to AD equals to DE, we will derive that DE is also equals to X. DE is also equals to X. Okay? So we will define angle BAD as theta. And because of the fact that in the right triangle, triangle ABD, angle BAD equals to theta, then angle ADB must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right triangle, triangle ABD, to 180 degrees. Why? Because theta plus 90 degrees minus theta is equal to 90 degrees, and 90 degrees plus 90 degrees, it is 180 degrees. Okay? And here we know that it is given as the question that triangle ABC is a right triangle, and therefore line segment BC is one side of the right triangle, triangle ABC. Therefore it is absolutely a straight line. BC, it is absolutely a straight line. I write it down. Line segment BC, it is a straight line. Must be a straight line, it's the side of a triangle. So we know that BC is a straight line. And we have the rule that states that the sum of the angles on one side of a straight line is equal to 180 degrees. According to this rule, if you focus on the upper side of the straight line BC, at point D, then the sum of the angles on the upper side of BC at point D must be equal to 180 degrees. So which angles we have at the upper side of the straight line BC at point D? We have here one angle that is equal to 90 degrees minus theta. We have also this angle that is a right angle, it equals to 90 degrees. And we have the third angle, the missing angle, angle EDC. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we will have 90 degrees plus 90 degrees, it is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we're left only with minus theta plus the missing angle, the angle EDC. It will be equal to 0. We will add theta to this equation and we'll get that the missing angle, angle EDC, is equal to theta. Angle EDC equals to theta. Okay, this angle, missing angle equals to theta. In the next step, we'll make a construction from point E. We will go perpendicular on BC. So this angle equals to 90 degrees and this angle will be also equal to 90 degrees according to our construction, and we will define the touching point of the perpendicular from point E and the BC as F. Actually we created here triangle EDF by this construction that is a right triangle. And in the right triangle, if this angle is theta, then angle DEF must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. In the next step, we will prove that those two right triangles can run to each other according to angle side angle rule. Okay, we will prove that the right green triangle, triangle ABD, is congruent to the right green triangle, triangle EDF, according to angle side angle rule. Okay, I'll write it down. We'll prove that the right green triangle, triangle ABD, is congruent to the right green triangle, triangle EDF. So why those two right green triangles congruent to each other? First of all, we have those two angles, they are equal to each other, they are both equal to theta. So you can write down that angle BAD in triangle ABD is equal to angle EDF in triangle DEF and both angles are equal to theta. I'll repeat again. Angle BAD equals to angle EDF and both angles are equal to theta. We also know that side AD is equal to side DE and both sides are equal to x. AD is equal to DE, and both sides are equal to X. Okay. AD equals to DE and both sides are equal to X. And finally, you also know that those two angles, they are equal to each other, they are both equal to 90 degrees minus theta. So you can write down that angle BDA is equal to angle EDF and both angles are equal to 90 degrees minus theta. I'll repeat again. Angle BDA equals to angle DF and both angles are equal to 90 degrees minus theta. So we actually proved that those two right main triangles can congruent to each other according to angle side angle rule. I write it down. Triangle ABD, the right main triangle, is congruent. This is the sign of congruent to the right main triangle, triangle EDF, according to side angle, according to angle side angle rule. Angle side angle rule. Here, why angle side angle rule? Why? Because those two angles are equal to each other, they are both equal to theta. Side AD equals to side DE, they are both equal to X. And those two angles, they are equal to each other, and they are both equal to 90 degrees minus theta. So those two main right angles can congruent to each other according to angle side angle rule. And from the fact that those two triangles can congruent to each other, we will conclude hence that AB equals to DF. AB equals to DF. If AB equals to DF, according to the rule that corresponding sides and congruent triangles are equal to each other. Those two main right angles can congruent to each other. Therefore, the corresponding sides, that is to say AB and DF, must be equal to each other. But AB equals to 6. It is given us in the question. You can write down that AB equals to 6. And from this equation, 6 equals to AB equals to DF, we will derive that DF is also equals to 6 units. Here we can write down that DF equals to 6 units. And what is the value of line segment FC of side FC? It is very easy to see from the drawing that FC is equal to DC minus DF. Again, DC minus DF equals to FC. I write it down. DC minus DF equals to FC. DC equals to 10 units. We just right now found out that DF equals to 6 units. In conclusion, we have found out that FC equals to 10 minus 6, that is 4. FC equals to 4 units. So I know that here that FC is equal to 4 units. Likewise, BD must be equal to EF. BD is equal to EF according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, therefore BD equals to EF. If we define BD as Y, if BD equals to Y according to our definition, then from this equation Y equals to BD equals to EF, we will conclude that EF is also equals to Y. So EF equals to Y. In the next step, we will prove that the right big triangle, triangle ABC, is similar to the right small triangle, triangle EFC. Okay? We will prove that the right big triangle, triangle ABC, is similar to the right small triangle, triangle EFC. So why those two triangles are similar to each other? First of all, they have two angles that are right angles, therefore they are equal to each other, they are equal to 90 degrees. So angle ABC is equal to angle EFC, and both angles are equal to 90 degrees. Okay? Yeah. Angle ABC equals to angle EFC. Angle ABC equals to angle EFC, and they are both equal to 90 degrees. This angle is a common angle, it belongs to both triangles. So can write down that angle ABC, angle ACB is equal to angle ECF and they are equal to each other because it is the same angle actually, it is a common angle. And those two angles are also equal to each other according to third angle theorem. So write it down, angle BAC, this angle is equal to angle FEC, this angle and they are equal to each other according to third angle theorem. I'll repeat again. Angle BAC equals to angle FEC according to third angle theorem. So what is third angle theorem? Actually, if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent because they are complementary to 180 degrees. Okay? So we actually prove that all the angles of triangle ABC, the right triangle, triangle ABC, congruent to all the angles of triangle, the right angle, triangle FEC. Therefore, we actually proved that the right triangle ABC is similar to the right triangle, triangle FEC according to angle similarity rule. Okay? from the fact that those two triangles are similar to each other, we will conclude that AB over BC in triangle ABC, AB over BC is equal to EF over FC in triangle EFC. I repeat again. From the fact that the two triangles can relate to each other, we conclude that AB over BC in triangle ABC equals to EF over FC in triangle EFC. AB equals to 6, so we substitute AB by 6. BC equals to 10 plus y. It is very easy to see that BC equals to 10 plus y or y plus 10. Okay, BC equals to y plus 10. And it is equal to EF, EF equals to y over FC, FC equals to 4. So in conclusion, we found out that according to equation number 1, 6 over y plus 10 equals to y over 4. Here we'll cross multiply equation number 1, and you will get that according to equation number 1, 6 times 4 is 24, and it is equal to y times y plus 10. Here we will open the brackets on this side of equation number 1, and we will get that 24 is equal to y squared plus 10y. We will subtract 24 from this equation, equation number 1, and we will get that according to we get that according to equation number 1, y squared plus 10y minus 24 equals to 0. This is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c in this general formula are the coefficients of a quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula. X it is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficients are as follows. The coefficient A is equal to 1, the coefficient B is equal to, this 10y of course, equals to 10, and the coefficient C is equal to minus 24, and the variable that we are looking for, the missing variable that we are looking for is y, so x equals to y. We'll put the data inside this equation for x, and we find out the values of x, because x equals to, and we'll find out the value of y, because x equals to y. So we get that according to the formula for x, y equals to minus b b is 10, so minus b is minus 10, plus minus square root of b squared. B is 10, so b squared is 10 squared is 100. Minus 4 times a is 1, times c is minus 23, a is minus 24, over 2a. A is 1, so 2 times 1 is 2. So here y is equal to minus 10 plus minus 4 times minus 24 is plus 96. 96 plus 100 is 196. And the square root of 196 is 14. So in conclusion, we actually found out that y equals to minus 10 plus minus square root of 196 is 14 over 2. So here we have two solutions that are possible for y. The first solution is y1 equals to minus 10 minus 14 is minus 24 over 2. Minus 24 over 2 is minus 12. And the second solution is y2 is equals to minus 10 plus 14 is 4, and 4 over 2 is 2. So the second solution is 2. We'll focus on the first solution. So y1 equals to minus 12. This solution is an incorrect solution because of the fact that y is the length of side BD of triangle ABD. Therefore, it must be a positive number. Y is the length, therefore it must be a positive number, and minus 12 is a negative number, so this solution is the correct solution. We'll cancel this solution, and we left only with the solution that y equals to y equals to 2. So if I will draw again the right triangle, triangle ABD, so we found out here that y equals to 2 units. And we will implement the Pythagoras theorem on the right triangle ABD in order to find out the value of x, that is the variable that we are looking for. Okay? So we will implement the Pythagoras theorem on the right triangle, triangle ABD. Here PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AD squared equals to AB squared plus BD squared. AD is x, so AD squared is x squared, and it is equal to AB squared. AB is 2, so AB squared is 4, plus BD squared. BD is 6, so BD squared is 6 squared, that is 36. So we found out that x squared equals to 4 plus 36, that is 40. Here we take root of this equation, and we get that x equals to the square root of 40. 40 is 4 times 10. And the square root of 4 is 2, so in conclusion we found out that x equals to 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. I repeat again, the answer to the question is that the length of line segment X, that is actually also equals to AD, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Here, the length of this line segment AD that is equal to X, it is equal to either 2 times square root of 10 units, or in terms of numbers, X equals to 6.32 units. So we finished with the second method. In the next step, I present to you how to find out the length of line segment X according to the third method. Okay? According to the third method, here we'll define angle BAD, this angle is theta, and we'll define BD as Y. So in the right triangle, triangle ABD, here tangent theta equals to BD over AB, PD equals to Y according to our definition, and AB equals to 6 according to what is given us in the question. So in conclusion, we found out that tangent theta equals to Y over 6. In the next step, we will focus on the right triangle, triangle ABC, the right big triangle, triangle ABC. In the right big triangle, triangle ABC, tangents theta plus 45 degrees equals to BC over AB. It is very easy to see that BC equals to Y plus 10 and AB equals to 6. So in conclusion, we found out that tangents, this is equation number 1, according to equation number 1, tangents theta plus 45 degrees is equal to Y plus 10 over 6. Okay, this is equation number 1. And we actually have trigonometric identity for tangent theta plus 45 degrees. Actually, the value of tangent theta plus 45 degrees or tangents, tangent theta plus 45 degrees is equal to 1 plus tangent theta over 1 minus tangent theta. So here we substitute tangent theta plus 45 degrees by 1 plus tangent theta over 1 minus tangent theta in equation number 1. And we get that according to equation number 1, tangent theta plus 45 degrees, according to this trigonometric identity, it is equal to 1 plus tangent theta over 1 minus tangent theta. And according to equation number 1, it is equal to Y plus 10 over 6. But we have already found out that tangent theta is equal to y over 6. So we substitute tangent theta in this equation, equation number 1, by y over 6. And we get that according to equation number 1, 1 plus tangent theta is y over 6 over 1 minus tangent theta is y over 6. And it is equal to y plus 10 over 6. Here we multiply 1 both the numerator and the denominator by 6, and then we divide it by 6 in order to have a common factor of y over 6 and y minus y over 6. So here we get that according to equation number 1, 6 plus y over 6 over 6 minus y over 6 is equal to y plus 10 over 6. Okay? Here we have 6 in the denominator and 6 in the numerator and 6 in the denominator, so 6 will get cancelled. What is left from equation number 1 after we cancelled 6? What is left? It is actually 6 plus y over 6 minus y is equal to y plus 10 over 6. Here we'll cross multiply equation number 1 and we will get that according to equation number 1, 6 times 6 plus y is equal to 6 minus y times y plus 10. We will open the brackets on both sides of equation number 1 and we'll get that according to equation number 1, 6 times 6 is 36, 6 times y is 6y, and it is equal to 6y plus 60 minus y squared plus 10y. So here we have 6y on both sides of the equation, so 6y will get cancelled. And according to equation number 1, we found out that 36 equals to 60 minus y squared minus 10y. Here we will add y squared and also 10y to this equation, equation number 1, and we will get that y squared plus 10y plus 36 equals to 60. We subtract 60 from this equation, equation number 1, and we will get that according to equation number 1, y squared plus 10y, 36 minus 60 is minus 24 equals to 0. So this is quadratic equation y squared plus 10y minus 24 equals to 0. We add it in the second method and we solve this quadratic equation and we got two answers for y. The first answer is y1 equals to minus 12 and the second answer is y2 equals to 2. But because of the fact that y is a length, it cannot be a negative number, so this solution is incorrect solution. And we have to live with the solution that y equals to 2. So I copied the right triangle, triangle ABD, in this new page, and we implemented the Pythagoras theorem on the right triangle, triangle ABD. In the right triangle, triangle ABD. We did it in the second method, but I will repeat on it. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x squared equals to 36 plus 4, x squared equals to 40, so x equals to the square root of 40. So here we have two solutions that are possible for x. The first solution, here we have x that is equal to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So it is not two solutions, but two ways to present the solution. One way is it is either x equals to either 2 times square root of 10 units, or in terms of numbers, x equals to 6.32 units. In the next step, we will summarize the lecture. Actually, we start with the first method. So we have here a right triangle, ABC, AB equals to 6, DC equals to 10, angle DAC equals to 45 degrees, angle ABC equals to 90 degrees, and we want to find out the value of line segment AD, that is x. So we did a construction, we extended line segment AD by a straight line, and then from point C we drew perpendicular to the extended AD. So this angle equals to 90 degrees, and we created right triangle, triangle AEC. In this right triangle, triangle AEC, the sum of the angles must be equal to 180 degrees. So which angle we have in the right triangle, triangle AEC that we created? We have here, this is 45 degrees, this is 90 degrees, and the missing angle is angle ACE. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we found out that the missing angle, angle ACE, this angle equals to 45 degrees. Then we define DE as y. So actually, side AE equals to x plus y. Then in triangle AEC we have two equal angles, and we know that in front of equal angles in the triangle there are equal sides. That is to say, in front of those two equal angles we have two equal sides. That is to say, AE equals to EC. AE equals to EC, but AE equals to x plus y. So from this equation, x plus y equals to AE equals to EC, we derive that EC is also equals to x plus y. Okay? Then those two angles, they are defined as vertex angles, and vertex angles are equal to each other. That is to say, angle BDA equals to angle EDC. So, and if we define one angle as alpha, then the other angle will be also equal to alpha. So those two angles are equal to alpha. And in the right triangle ABD, if this angle equal to alpha, this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in the triangle to 180 degrees. Here, if this angle equals to alpha, this in the right triangle DEC, this angle must be also equal to 90 degrees minus alpha. So here, we actually proved that those two main right triangles are similar to each other. Why? Those two angles are equal to each other, they are both equal to 90 degrees minus alpha. Those two angles are also equal to each other, they are both equal to alpha. And those two angles are also equal to each other, they are both equal to 90 degrees. So we actually proved that all the angles of triangle ABD can go into all the angles of triangle DEC. Therefore we proved that triangle ABD is similar to triangle EDC according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that AB over EC equals to BD over DE equals to AD over DC. Okay? And here AB equals to 6, EC equals to x plus y, BD is BD, DE equals to y, AD equals to x, and DC equals to 10. We found out the value of BD by implementing the Pythagoras theorem on the right green triangle, triangle ABD. According to the Pythagoras theorem, AD square equals to AB square plus BD square. Okay, AD square equals to AB square plus BD square. AD equals to x, so AD square is x square, and it is equal to AB square. AB is 6, so AB square is 6 squared, that is 36, plus BD square. We subtracted 36 from this equation and found out that BD equals to x square minus 36. We took out of this equation and found out that BD equals to the square root of x square minus 36. Now we can substitute BD in this equation number 1 by square root of x square minus 36. We did it, and we got that according to equation number 1, 6 over x plus y equals to BD, that is x square root of x square minus 36 over y, that is equal to x over 10. So here, those two expressions, they are equal to each other. That is to say, we created equation number 1 that states that 6 over x plus y equals to x over 10. We cross multiply this equation number 1, and we got that 6 times 10 is 60. 60 equals to x times x plus y. We open the brackets here, and we got that 60 equals to x times x, that is x squared plus xy. We subtracted x squared from this equation number 1, and we got that xy equals to, according to equation number 1, equals to 60 minus x squared. Then we created the second equation from this long equation. Actually, those two expressions, they are equal to each other. That is to say, according to equation number 2, square root of x squared minus 36 over y equals to x over y. Because multiplying this equation number 2, and found out that 10 times square root of x squared minus 36 equals to x plus y. So we have two different expressions for xy. Equation number 1 and equation number 2. Then we created equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. That is to say, xy according to equation number 1 is equal to 60 minus x squared, and it must be equal to xy according to equation number 2, that is equals to 10 times square root of x squared minus 36. Here we squared both sides of equation number 3, and we got that here 60 minus x squared equals to 10 squared, that is 100, and here the square cancels the root, and we left only with x squared minus 36. We opened the brackets on both sides of equation number 3, and we got that 60 minus x squared is 60 squared, that is 3600, plus x squared is x to the power of 4, minus 2 times 60 times x squared equals to 100 times x squared, minus 100 times 36 is minus 3600. We added 3600 to this equation number 3, and we got that 3600 plus 3600 is 7200, plus x to the power of 4 minus 2 times 60 is minus 120 x squared, and it equals to 100 x squared. We subtracted 100 x squared from this equation number 3, and we got that x to the power of 4 minus 120 x squared minus 100 x squared is minus 220 x squared, plus 7200 equals to 0. Then we substituted minus 220 x squared by minus 100 x squared minus 40 x squared, and we got that according to equation number 3, x squared minus 100 x squared, x to the power of 4 minus 180 x squared minus 40 x squared plus 7200 equals to 0. So here we took a common factor from those two expressions. The common factor is x squared. Inside the root we have x squared minus 180. Here we took minus 40 as a common factor out of those two expressions. Inside the brackets we have x squared minus 180. And we took x squared minus 180 as a common factor out of those two expressions. And inside the brackets we have x squared minus 40. So here we will have two solutions that are possible for this equation number 3. The first solution is either x squared minus 80 equals to 0, or x squared minus 40 equals to 0. According to the first solution, x squared equals to 180, and 180 is 36 times 5. We took out of this equation and we found out that x equals to the square root of 36 times 5. The square root of 36 is 6 times square root of 5. So in conclusion, we found out that x equals to 6 times square root of 5, that is 13.41 units, that is greater than 10 units. And the second solution is x equals to 6 times square root of 5. So according to the first solution, x equals to 6 times square root of 5, that is 13.41 units, that is greater than 10. According to the second solution, x squared minus 40 equals to 0, that is to say x squared equals to 40. We took the root out of this equation number 2, and we found out that x equals to the square root of 40, and the square root of 40 is 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units, that is less than 10 units. Okay, then I draw triangle ABD and triangle ADC in the new page. Angle ADC is an exterior angle of triangle ABD, and triangle ABD has three interior angles, theta, 90 degrees, and alpha. So here angle ADC is an exterior angle of triangle ABD. And we have rule number 1. According to rule number 1, an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So here, the value of the exterior angle ADC according to rule number 1 will be equal to the sum of the two interior angles of triangle ABD that are not adjacent to it. Angle alpha is adjacent to angle ADC, therefore the two other interior angles that are not adjacent to it is theta and 90 degrees. So the value of the adjacent angle, the value of the exterior angle ADC will be equal to 90 degrees plus theta. Here we found out that so the exterior angle is 90 degrees plus theta, and then I presented to you also rule number 2. According to rule number 2, but before rule number 2, we know that the sum of the angles in any triangle is 180 degrees, and especially in triangle ADC, the sum of its angles must be equal to 180 degrees. Which angle we have in triangle ADC? We have here 45 degrees, and we have angle 90 degrees plus theta, and we have the missing angle ACD. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we got that theta plus ACD equals to 180 degrees minus 135 degrees. This is 45 degrees. We subtracted theta from this equation and found out that the missing angle ACD, this angle equals to 45 degrees minus theta. From this drawing, you can see that this angle ACD is the smallest angle in triangle ACD, because it equals to 45 degrees minus theta, and this angle is 45 degrees, and this angle is 90 degrees plus theta. So angle ACD, that is equal to 45 degrees minus theta, is the smallest angle in triangle ACD. Okay? And according to rule number 2, the smallest angle in a triangle is always opposite the shortest side. So this smallest angle, angle ACD, is opposite the smallest side. That is to say, AD that is equal to X, it is the smallest side in triangle ADC. What does it mean? It means that AD that is equal to X is less than 10 units, because it is the smallest side. It is the shortest side. So AD that is equal to X is less than side DC, because it is the shortest side. So AD that is equal to X is less than 10, because DC equals to 10. So we found out in conclusion that X is less than 10 units. X side AD that is equal to X must be less than 10 units. And here we have two solutions that are possible for X. The first solution is X equals to 6 times square root of 5 units. That is actually 13.41 units. and 13.41 units is greater than 10. But x must be less than 10 units. So this solution is an incorrect solution. We cancel the solution and we left only with the second solution, that x equals to 2 times square root of 10 units. That is actually 6.32 units. That is less than 10 units. And so the solution to the question that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Then I presented to you how to find out the value of line segment x by using the second method. According to the second method, we made another construction from point D. We drew a straight line on AC in such a way that angle AED is equal to 45 degrees. So in triangle ADE, we know that the sum of the angles must be equal to 180 degrees. Which angles we have inside triangle ADE? We have 45 degrees and 45 degrees. And we have this angle, that is angle ADE, it is the missing angle. So 45 degrees plus 45 degrees is 90 degrees, plus the size of the missing angle, that is angle ADE. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation and found out that the missing angle ADE is equal to 90 degrees, because 180 degrees minus 90 degrees, it is 90 degrees. So this angle ADE equals to 90 degrees. And we also know that in front of equal angles in the triangle there are equal sides. That is to say, those two angles are equal to each other, therefore AD must be also equal to DE. AD must be equal to DE, but AD equals to x. From this equation, x equals to AD equals to DE, we will conclude that DE is also equal to x. Then we know that in triangle ABC, BC is one side of triangle ABC. Therefore, BC is a side of a triangle. It must be a straight line. BC is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles on the upper side of BC at point D must be equal to 180 degrees. So which angles we have in the upper side of BC at point D? We have 90 degrees minus theta, we have 90 degrees, and we have the missing angle ADF. In total, or ADC, in total the sum of those three angles must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we left only minus theta plus angle EDC equals to 0. We added theta to this equation and found out that the missing angle EDC equals to theta. So this angle equals to theta. So then from point E we do perpendicular on BC. So this angle equals to 90 degrees, and this angle is also equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point E and BC as F. So we created here right triangle. In this right triangle, if this angle is equal to theta, then this angle must be equal to 90 degrees minus theta. Then we proved that those two right triangles can go into each other. Why they can go into each other? First of all, those two angles, they are equal to each other, they are both equal to theta. Side AD equals to side DE, and both of those two sides are equal to x. And those two angles, they are also equal to each other, they are both equal to 90 degrees minus theta. So we actually proved that triangle ABD, the right triangle, is congruent to triangle EDF according to angle side angle rule. From the fact that those two triangles can go into each other, we conclude that AB is equal to DF. AB is equal to DF according to the rule that corresponding sides of congruent triangles are equal to each other. But AB equals to 6 according to what is given as the equation. So from this equation 6 equals to AB equals to DF, we conclude that DF is also equals to 6. And if DF equals to 6, what is the value of FC? You can see it is very easy to see that FC equals to DC minus DF. Okay? here FC is equal to DC minus DF, DC equals to 10, DF equals to 6, so FC equals to 10 minus 6, that is 4. So we found out that FC equals to 4 units. Likewise, BD must be equal to EF because of the fact that those two triangles can go into each other. BD equals to EF according to the rule that corresponding sides of congruent triangles are equal to each other. Therefore, BD equals to EF, and if we define BD as Y, then from this equation Y equals to BD equals to EF, we derive that EF is also equals to Y. Then we proved that the right big triangle, triangle ABC, is similar to the right small triangle, triangle EFC. Why those two triangles are similar to each other? First of all, both those two triangles have right angles, one right angle, and they have this angle that is a common angle, it belongs to both triangles. And those two angles are also equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. Why? Because they are complementary to 180 degrees. So we prove that all the angles inside triangle ABC congruent to all the angles of triangle EFC. Therefore, we prove that those two triangles are similar to each other. Okay? Triangle ABC is similar to triangle EFC according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that AB over BC, triangle ABC, equals to EF over FC in triangle EFC. Okay? AB over BC equals to EF over FC. AB equals to 6, BC equals to Y plus 10, EF equals to Y, FC equals to 4. We cross multiply this equation and we got that 24 equals to 4 times Y plus 10. We open the brackets here and we got that 24 equals to y squared plus 10y. We subtracted 24 from this equation, equation number 1, and we found out that y squared plus 10y minus 24 equals to 0. This is a quadratic equation, and the general form of a quadratic equation is ax squared plus bx plus c equals to 0. And the ABC are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to b, the coefficient b equals to 10, and the coefficient z equals to 24. And x equals to y is the missing variable that we are looking for. We put the data inside the equation for x and we found out the value of y. Because x equals to y equals to minus b equals to 10, so minus b is minus 10, plus minus b squared, b equals to 10, so b squared is 10 squared, this is 100, minus 4 times a is 1, c is minus 24. Minus 4 times minus 24 is 96, and 96 plus 100 is 196, and the square root of 196 is 14. So in conclusion, we found out that y equals to minus 10 plus minus 14 over 2. So here we have two solutions that are possible for y. The first solution is y equals to minus 10 minus 14 is minus 24 over 2, that is minus 12. And the second solution is minus 10 plus 14, that is 4 over 2 is 2. The first solution is the correct solution because it is a negative solution, and y must be a positive because y is a length, and the length must be a positive number. So we cancel this solution and we left only with the solution that y equals to 2. So we implemented the Pythagoras theorem in this right triangle, triangle ABC. According to the Pythagoras theorem, AD squared equals to AB squared plus BD squared. AD is x, so AD squared is x squared. AB is 6, so AB is 6, so AB squared is 36. BD is 2. BD squared is 2 squared, that is 4. 4 plus 36 is 40. So in conclusion, we found out that x squared equals to 40. We took a root out of this equation and found out that x equals to either 2 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the second method. Then I presented to you how to find out the value of x according to the second method. In this method, we defined angle BAD as theta and side BD as y. Here we know that tangent theta and the right triangle ABD is equal to BD over AB. BD is y, AB is 6. So in conclusion, we found out that in the right triangle ABD, tangent theta equals to y over 6. Then we focus on the right triangle ABC. In the right triangle ABC, tangent theta plus 45 degrees equals to BC over AB. BC equals to y plus 10 and AB equals to 6. So according to equation number 1, we found out that tangent theta plus 45 degrees, in conclusion, it is equal to y plus 10 over 6. Then we have trigonometric identity for tangent theta plus 45 degrees. Here, tangent theta plus 45 degrees is equal to 1 plus tangent theta over 1 minus tangent theta. That is to say, we can substitute tangent theta plus 45 degrees in equation number 1 by this expression. We did it, and we got that 1 plus tangent theta over 1 minus tangent theta equals to 1 plus 10 over 6. Then we already found out that tangent theta equals to y over 6, so we can substitute tangent theta by y over 6. We did it, and we got that according to equation number 1, 1 plus y over 6 over 1 minus y over 6 equals to y plus 10 over 6. Then we multiplied 1 by 6, and then we divided by 6 in order to have a common factor with y over 6 and minus y over 6. So we got here that 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. Here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled, and we left only with 6 plus y over 6 minus y, that is equal to y plus 10 over 6. We multiplied the equation number 1, and we got that 6 times 6y equals to 6 minus y times y plus 10. We open the brackets on both sides of the equation. 6 times 6 is 36, 6 times y is 6y. Here we have 6y plus 60 minus y squared minus 10y. We have 6y on both sides of the equation, so 6y will get cancelled, and we left only with 36, that is equal to 60 minus y squared minus 10y. We subtracted we added y squared and 10y to this equation, and found out that y squared plus 10y plus 36 equals to 60. We subtracted 60 from this equation, and we found out that y squared plus 10y minus 24 equals to 0. So this we solved this quadratic equation in the second method, and we had two solutions. The first solution is minus 12, but it is not correct solution because y is a length and it must be a positive number. Therefore, only the second solution is true, that y2 equals to 2. So here we found out that dB equals to 2, AB is 6, it is given as the question, and AD equals to x. So we implemented the Pythagoras theorem on the right triangle ABD. According to the Pythagoras theorem, AD square equals to BD square plus AB square, that is to say x square equals to 6 square plus 4, x square equals to 40. We took out of this equation and found out that x equals to either 2 times square root of 10 units, or in terms of numbers, x equals to 6.32 units. So the answer to the question is the length of line segment x, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, thank you very much.